Hello, class, and welcome to our fourth week of teleschool. All right, and we are talking about chapter 11, which is electricity and magnetism. All right, so in order for us to appropriately talk about electricity and magnetism, we have to go back and talk about our chemistry. All right, all right. So we talk about chemistry, and we talked about chemistry last semester. Okay, so all matter is made up of atoms. All right, and atoms are made up of our three subatomic particles. I'm sure you remember them: protons, which are positive, neutrons, which have no charge, all right, and then electrons, which are negative. All right, so atoms can have no charge when your number of protons, all right, the number of protons, which would be like a positive 6, so if it had 6 protons, plus negative 6, so 6 electrons, all right, and when you add those two together, all right, you're going to have a charge of 0. And mostly when we talk about charges or when we talk about atoms in general, okay, we are going to be talking about our electrons and our protons, okay? Those are the big guys right there. All right, neutrons are important, but we don't really talk about them so much as we talk about these other two. All right, so atoms can have a positive charge when it has more protons than electrons, and those are called cations. Okay, so if you have 6 protons, all right, plus negative 5 electrons, then you're going to have a positive 1 charge. All right, I'll switch over colors. Okay, and if an atom has a negative charge, okay, that's when it has more electrons than protons. All right, so if you have plus 5, okay, 5 protons plus negative 6 or 6 electrons, all right, you're going to get a charge of negative 1. All right, so it works just like any other math course, okay? So if you have more positives than negatives, you're going to get a positive number, all right? Or if you have more negatives than positives, you're going to get a negative number. So that's just a review from last semester, okay? So here we're looking at in carbon atom, all right? Remember, carbon is the big C, all right? We have 6 electrons, all right? And then we have 6 protons, although it doesn't show all 6 here, they're probably hiding behind, okay, behind the neutrons inside the nucleus. Remember, the nucleus is made up of protons and neutrons. All right, and then the neutrons really have no effect on what the charge is going to be, okay? So if we're looking at this carbon atom, all right, without doing anything, okay, it's going to have a neutral charge because it just is not going to have anything going on there, okay? So the law of conservation of charge, okay, and we talked about the law of conservation of mass and then the law of conservation of forces, okay? All of those things are all relevant. So this states that charges can be transferred from one object to another, but cannot be created or destroyed. And that makes sense because matter cannot be created or destroyed, and matter is made up of atoms. Yay. All right, so an electric charge, all right, so electrical charge occurs when atoms are stripped of their electrons by an external force. All right, so we have our atom here, and then we've got our little cloud of electrons floating around it. All right, if those electrons are just kind of ripped away from it, all right, they're all ripped away. Goodbye, my electron friends. All right, this creates charges. All right, so positive atoms have had electrons stripped. So, i.e., they have more protons and electrons like we discussed last time. So if we have a positive charge on our atom, all right, that means that we've had more electrons ripped away, and therefore there are more protons and electrons. And then negative atoms have gained electrons by stripping them away from another atom. For example, if you had one atom that had 2 electrons, and then one atom that has, let's just say, 6, all right, if this guy rips away these 2 electrons, this one is going to have a positive 2 charge, and this one's going to have a perfect octet. So this one's going to be happy, okay? And because of the law of conservation of charge, the overall charge is always conserved, okay? And we call the base unit of electric charge, all right, coulombs, all right, or C, okay, capital C. So another point in which we recognize that there's going to be units involved. Just like all chemistry concepts or physics concepts, we always are learning more about the units. And when we're talking about electric charge, we're talking about coulombs. All right? That one would probably have a negative 2 charge if we were just looking at it that way. Okay? But that aside, let's go to the next slide, okay? So attraction. So charge exerts forces of attraction and repulsion, all right? So if you're attracted to somebody, that means you like them, right? So attraction, the force between oppositely charged particles attract each other. So I'm sure you've heard the term opposites attract, all right? So your positive is going to be attracted to your negative, okay? So let's look at this inside an example that you might be a little bit more familiar with, okay? So if you are looking for somebody, a significant other, okay? And in order for you to be attracted to them, and this is a little bit of a silly example, but I'm sure it will do the trick, okay? So here is the girl here, all right? And then here is the boy, okay? Or whatever you want to think of, okay? In order for the girl to be attracted to this individual, all right, he has to like pickles, okay? Because she does not like pickles. Because she does not like pickles. So, in order for her to be attracted to this individual, they have to like pickles. And if they like pickles, then that means when she gets a burger or something of that nature, she can donate her pickles to him. All right, so let's look at it this way. If you are repulsed, or the repulsion factor, okay, the force between the particles of the same charge repel each other. So let's take a look at the pickles example again, and let's just say that she actually likes pickles, and he also likes pickles, okay? If they both like pickles, all right, then there's going to be potentially a fight between them, because if she likes pickles and he likes pickles, then there is going to be a fight over who gets, theoretically, the last pickle inside the pickle jar. Okay? So, attraction means that you are attracted to somebody with, different, in this case, different charges, but maybe likes and dislikes. So that, if you like something and they don't like something, then they can give that thing to you. All right? Or if we're looking at repulsion, okay, if you like pickles and he likes pickles, then that means that nobody's going to be donating pickles because you want to keep them, right? And if there's only one pickle inside the pickle jar, then you're going to fight over it. Okay? That's kind of a silly example, but I bet you will not have trouble remembering it. All right. So forces of attraction and repulsion depend on the amount of charge and distance between those charges. The greater the distance, the smaller the force. And that makes sense because if you have two things, let's just say you have one thing over here and then it's 7 miles to get to the next thing, all right, you're going to have a smaller force. But if you have two things that are sitting right next to each other, so perhaps 2 inches, all right, they're going to have a much stronger force. All right, so let's look at an actual modern example. Hopefully you all have done laundry at least once or twice inside your lives. Okay, have you ever pulled your clothes out of a dryer and noticed them sticking to each other? All right, this is called static electricity. All right, or an accumulation of excess electric charge on an object. All right, and I'm sure you guys have seen static electricity. You know, that's the thing that if you have a person right here, okay, that's what's going to make their hair stand up. If, you know, they rub a balloon against their head, I'm sure you guys have done that before. All right, or, you know, you have pieces of clothing when you pull it out of the dryer, you notice that everything's sticking together and then it makes a weird, I don't even know if I could replicate the sound, but it makes a very specific electric sound. That sounds kind of silly. Okay, guys, but that is static electricity. All right, and then you can click on this picture here and watch this quick video on static electricity. But just know, all right, so when somebody asks you, why are my clothes sticking to each other right out of the dryer? And you can say, oh, it's from static electricity, or it's the accumulation of excess electric charge on an object. Simple enough, right? All right, so electric force occurs when an atom enters another atom's electric field. All right, so an electric field surrounds every atom and exerts the force that causes other electric charges to be attracted or repelled. All right, so this is a proton, okay, and then it's going to try to attract a negative force, okay? So all of the forces around it are just aiming for that negative force, okay? If it was trying to pair up with a proton, which it wouldn't do naturally, all right, you would have the opposite of that force leading back into it because it does not want to have those protons next to it. So any charge that is placed in an electric field will be pushed or pulled by the electric field surrounding the charged particles. And you guys have seen a good example of this, okay? If you guys have ever played with magnets, like on your fridge or something, you'll notice that even though you're trying so hard to put them next to each other, there's going to be this invisible force that will not let you actually stick them together, okay? And that's due to the electric field. All right, guys?